Good morning, sir. I'm Naavind Balan from FTKE Industrial Power. So today I'm going to discuss about the control system design. That is Lab 1, Introduction to the Simulation, Simulink and Open Loop System Characteristics. So from here, I'm following the every instructions that they are given. So to do the step transfer function and scope to see the output on the transfer, what are the transfer functions do and the scope output. So I just try doing this. Then for the first task 2.5, so I just insert the value of 1 divided by s plus 1. So the value should be, the graph should be like this, because there are some transfer functions inside this. So the value will hide after the transfer functions once it reaches the value, and the output will be response. So the same goes to here. This one is for 9 divided by s square plus 2s9, and then 625 over 2 s square plus 625, and then 10 or divided by 2 s square plus 3s plus 5. So the ripple, it will hike up until 9. So it will get like this, and then the waveform will be standard once it reaches the value to the output. So it's same goes to 2b. So for the 125, it will be very close in every wave. So it will ripple like this. Once the transfer function will clear, then we can see the steady state response. The same goes to the 10 over 2 s square plus 3s plus 5. So the output like this. Okay. For the discussion, this one I will understand by the system behavior, and the stability is made easier by doing this lab. This amplitude and the timing of the step change are both programmable. So the dynamic behavior of the system is represented by the transfer function block. It is a mathematical illustration of how the system's output reacts to the modifications in the input. So the block diagram can be represent a variety of a system, such as mechanical systems, electrical circuits, and moreover. So these block transfer functions, which can be an intricate mathematical equations that describe the system behavior. Okay, for the conclusion, this transfer function block is a mathematical representation of a relationship between the input and the output of the system. It is defined how the system process and transfer the input signal into an output signal. So the functions of a programmer of analyzing and designing control system, filters, and various dynamic system. And the scope block is a visualized tools that allow you allow us to view the analysis of the system response and display the output of the system over time, and making it easy assess the system behavior and make necessary adjustment on the transfer functions. So for the second part, open loop system characteristics. So just follow the instructions based on this one, the input, the plan, and the output for the first order. So this one we only have the output process, input process, and time constant, steady state gain, process gain, and process transfer function. So, but for the second order system, they have an additional part, is a damping factor. Same goes as output, input, time constant, and process gain. But here is additional damping factors. So the process of transfer function. So the value just need to be modified over the transfer function. So for the question 1, we just follow the procedure. For the K, value on the upper side and the top on the bottom as result as shown in formula. So just insert the value so we can see the actual value plus the damping value and the overall value for the true question. And then this is the same goes here, but we only change that uh, value of the top and the k. So this is the output for the result for the 1a step. It's a step, ramp, and impulse response. So same goes to 1.1b. So this one is for step, ramp, and impulse response. For procedure 2, so for the procedure 2 is following by the second order. So for the second order, this one is the formula for us to for me to follow it, and then this is the formula. So after the formula insert, okay, where with the value you get the response function, the result for three questions, four, and then this one the discussion is about the absence of the lack of the input is what most the distinguish open loop system for other type of system. It indicates that the system does not continually check and adapt its output. So then the deterministic response are proceed by an open loop system, which means that the output is totally foreseeable given the input. There are no adjustments to the shifting circumstances or disruptions. So the open loop system may be less complicated to operate and more economical as a result in the simplicity. Restrictions sturdiness a system that operates in an open loop are less resilient to outside disruption and change in the environment. For the conclusion part, the absence of open loop feedback system function without an assistance of the feedback data. Because the open loop system don't need sensor feedback loop or control algorithm, then the frequency easy to build the operate. Behavior in when the input and external variable are constant, the open loop system can be displayed respectively and predictable behavior. They are less appropriate for the situations where disruptions and charge in the process. So in the conclusion, the open loop systems are simple and affordable, but they are unable to adjust the change or fix mistake instantly. They work well in situations and predictable. So predictable performance significant for the significance of the task that hand and dynamic reactions and accuracy are not essential. To closed loop control with fleet lab mechanism is the best option for the increasingly complicated and important system. Thank you, sir.